Well, howdy, y'all, and welcome to another high-powered episode of the High Voltage Live Show. I'm your host, Willie Snyder from NEC Code, coming to you live from the Mile High City in Denver, Colorado. I am joined by my awesome partner, Mr. King James Salcup of the Volt Online Academy, CEO and founder of the best online training you will get, hands down. We challenge anybody to send their best over and compare it, and we'll show you what the best looks like. And really awesome that you put all this work into this, James. And graphics look awesome. All the music that I sent you sounds great, and we're getting it put together. You put some of your own music together. It's really awesome. I really appreciate all the participation we've had in NEC for Dummies. Nat King Code has just exploded. I think I got 63 new followers just this month. So it's really awesome. Everyone's enjoying the content. We're putting out all kinds of just cool stuff every week, and I'm getting feedback from a lot of people that's telling me different things that's that they like to see. They say they really like getting their code book out and kind of looking for these things. When you're on an exam, you need to find these in about roughly 5 minutes is what they give you to find these. So it's kind of cool because a lot of the guys, when they're studying for an exam, they could take these code questions of the week and they could just look them up and find them within 5 minutes, and they know that they're ready on that one question. So a lot of the questions that I found, I got from an exam book, and I've been just going through, trying as hard as I can to try to stump James. I feel really bad though, bro. I'm gonna go real easy on you. This Willie Quiz, I made it like super easy this week because I feel bad. James is like 2-12 so far, and like I say, I'm like, no, you're gonna get them all right this week because
No, I'm not. No, I'm not.
like, I just made them easy though. It's a lot easier. It should be just common sense, but you never know because I might just maybe switch it up a little bit, on you, but now that I do sometimes do the over under a little differently, and so we'll see. But you have a 33% chance. You know what I mean? So I'm raising the odds on you there. You got
All right,
33% chance to get it right.
I'm with it. I like to try anything. So, and
Yeah.
plus we got a new segment this week from the Wall of Shame, and basically we're going to pick a picture out each week and just sort of laugh at it, and
Yeah.
the installation, just have fun with it. So,
Yeah, maybe throw up a few references. But yeah, feel free. It's called the Electrical Wall of Shame. And the picture that's up there was actually a service call that I did. And there's just so many code violations. I was like, this has to go on the Wall of Shame picture. But feel free. We'll put a post up in the Wall of Shame, and then feel free to just add your craziest pictures in there, and we'll try to see if you win. I don't know. You picked this week, right? So I'll probably be picking next week, right?
I just took the one that we had from last week uh,
Okay.
that we are going over because there were a lot of violations there. So we were like, oh, let's go with that one. So,
Okay. Sounds
you
good.
ready for the meme
Awesome.
of the week?
Let's do it.
All right, here we go.
So that one's kind of an oldie but a goodie. But the thing that's so funny about it was that a lot of people, we kind of got in this argument with these guys where they say, like, in recess cans, they take the Wagos and they cut them out and they put wire nuts in there. And that could, and I don't know, you'd probably be familiar with this, James. If you have a field evaluation body come in and they find out that you cut all those factory Wagos out of there, you could be in some hot water with a listing agency because that's illicit equipment. And if they're starting to have problems and they come to find out it's one of those wire nuts, then they're gonna push all the liability back on the contractor for
Sure, they will. You
altering
can't
that equipment.
you can't go and break the listing and labeling of equipment by altering it or modifying it any means. And it's like when we had they were, oh, this has been what, 2.5 years ago, you know, when we had the discussion and they were saying that there was an outlet there at the AC unit. And I said, no, there isn't. And I said, but just to be fair, I said, let's say there is. I said, is that rated for a wet location? And they said, what the hell's that got to do with it? I said, well, when they do the listing and labeling of the equipment, they take not only the UL standards and other NFPA standards, but also the National Electrical Code into consideration. And if they're considering that to be an outlet in there, then it'd have to be rated for a wet location, just like the wiring and everything else that's outside.
And, well, yeah, and you kind of have to take it even all the way through the whole line and say, okay, so if you have a 277 volt RTU up on the roof, is that a 277 volt 3-phase outlet? You know, mm-hmm. And you're kind of getting in some you know, thick waters that's full of gators when you start doing some of these interpretations. And I'll take it kind of a step further. Some of my guys, when we're going in these big units, some of these 5-ton, 10-ton units up on the roof, they're like, hey, do we have to be in seal tight all the way through the unit? I'm like, no, because that's a dry location.
That's right.
So is their wire in seal tight? No, because the manufacturer lists that as a dry location.
That's right.
Basically, we could be wild and they could be wild. I usually like to turn 90s and hug, you know, use sticky backs and hug nice and make it look neat, you know. But at the same time, you know, that's kind of a tough thing because you're basically at least a damp location in there from if you were going to go off to NEC, you know.
That's right. And that was my whole point with them. You know, that's not listed in that location like that. And that's what I was trying to say. If the manufacturer intended it as such, it would be listed that way. It's no different than having a box that's outside that's rated for a wet location. It says it on there. You don't see that on the AC unit. And the reason is because they're not using it per the NEC. And that was my whole argument. So they got off of that and now they're on to something else. But, you know, yeah. It's like I've always said, you can't pick and choose in the code where you want to apply something. You have to take all of it together. And you never want to break the listing and labeling of the equipment and do any type of modifications whatsoever. So just like those Wagos, you're breaking what that listing and labeling is because there's a reason they're using those Wagos in there.
Yeah, and I always argue with these guys because they bring up like the skin effect and stuff, and they bring up like these air gaps and stuff. And what we found by checking it out is in these like low ampacity applications, such as like a recessed can or something, you're not really going to see the skin effect. The skin effect is not really present until you start getting up to these like higher ampacities and higher voltages and stuff where you actually start needing to worry about that. So these Wagos are basically listed the same exact thing as a wire nut. They're and a lot of people have said they've actually seen more problems on service calls from incorrectly installed wire nuts than incorrectly installed Wagos. And typically that if you don't install something correctly, you're going to have problems with it. But that brings up this week's myth of the week that we are going to run, and basically it is about the breaker listing. And we'll see how this goes. This has kind of been like a controversial topic I've heard, but basically this week's myth is 80% breakers.
It won't be controversial after this because I'm going to show where all this comes from. And nice. It was funny because I was talking to you. I didn't know that was in there, but you got to go back quite a few cycles in the NEC to know it's there. So, nice. But the only reason I know is because we've been doing the publications for 35 years, and we actually have that as a design tip in the design book explaining exactly what we're about to talk about for Myth of the Week. So let me go ahead and run it.
Awesome.
It's time for Myth of the Week.
All right. Well, I really appreciate all the participation we had this week. I had a great time doing this. There was some really excellent comments in there. I think it was pretty much all the way across the board. Everyone got this right. I don't think anyone got this wrong. But we had some really interesting comments, and the basically the equation that I set up was, and I've done this a bunch of times, so everyone that knows me from all the groups, I've done this a bunch. I say, okay, you have a refrigerator, a garbage disposal, and a dishwasher, and the combined load is 17.7 amps. Can you put that on a 20 amp breaker? The answer is absolutely yes, you can, because those loads are all non-continuous loads. So that's where this all comes in, and you can see that that's actually the triggering language that's in here for supplying continuous loads. Continuous loads is actually really confusing to a lot of people, because that means that that appliance has to run continuously at full load for 3 hours or more. So you have to look at a refrigerator. Is that a continuous load? Nope. It runs for maybe, let's just say it runs for an hour. It runs for an hour, gets to its temperature, shuts off. I really yell at my wife every time she runs the garbage disposal for 3 hours, but most of the time it's for about 3 seconds. But, like when you look at it like a dishwasher, a dishwasher is not going to run typically for a 3 hour cycle. They're usually like a 60-minute cycle,
Wow.
so that's kind of where it comes in, to where the confusion comes in with this, that a lot of guys, and I'm not going to name names, there's some certain code people out there that just say just do everything continuous, then you never can go wrong. But to me, that doesn't pass you an exam, and that doesn't make you a knowledgeable electrician out in the field. So we like to bring the truth and just like show everyone that, if you are all non-continuous loads, you can load all the way to 20 amp, and you could actually load that to 100% of its ampere rating, which is 20 amps. So,
Cool.
and I know James is going to bring up all kinds of stuff that I didn't know, so I'll let you move forward with this one.
All right. Well, the first thing is, if you go back, before it got to 1999 NEC, it was 1996, and it was actually 384-16C. And then it got moved to 384-16D. And then when we got to the 2002 code, this was deleted. Okay. I actually had to go back and look exactly when it was, and I was correct where I thought it was going to be. But when you look at the continuous load here, and it talks about overcurrent protection, it says the total load on any overcurrent device located in a panel board shall not exceed 80% of its rating, where in normal operation, the load will continue for 3 hours or more. So that's basically telling you this is a continuous load. So in other words, if I take a 20 amp breaker at 80%, that's going to give me 16 amps. If I take 16 amps times 125%, that's going to give me 20 amps. Okay.
Right.
So basically the reciprocal of 80% is 125%, is basically what they did here. Now, what used to happen, and the reason that they took this out, was because people would take and go look, and I'll show you these sections in a minute, but they go look at 210.19A or 215.2A, and they would take the continuous load at 125% and the non-continuous load at 100%. Then they get the amperage, and they would go take the breaker and then take 80% of that breaker to protect that load, and that's not what you did. That's
Okay.
where the problem came in. And
I got you.
And I can't even remember, somebody actually had it in one of their publications. There's like one or two of them actually showing to do that, and they said no, that's not going to work. So
Right.
they took that out. Now, one of the interesting things that also happened through all this, and I think I was trying to think, I think it was Miller who made a proposal when they started getting into adjustment and correction factors, and you notice now we do that different because actually, if you took and this used to be in our publications that way too till they made the change, but you used to take adjustment and the correction factor plus the continuous load, and basically you could actually, if you had all three of them present, you could have three derating factors there. So what they did, they took the continuous load away from all of that, and it's done separately now at 125%, and then the adjustment and correction factors are done separate from the continuous load. And you'll remember we did a calculation before where I showed doing a continuous calculated load and doing that method one. Then we did a method two, and I showed where you did an adjustment and correction factor at 100%.
Yeah, and I was actually, just before you were going to say that, I was wondering why they would take this out. But that actually makes a lot of sense because there's no reason to derate things twice, just the same way there's no reason to GFCI protect things twice.
That's right. And that's why all of this is being set up like this and why certain things were taken out. Now, when you go over from there and you go look at Article 100 just as it is now, it tells you a continuous load is anything that operates for what? 3 hours or more. Okay? And then right when you go over now and you look at 210.19A, just like I was talking about, if you look at the general requirements in A1, it talks about where a branch circuit supplies continuous loads or any combination of continuous and non-continuous. It tells you to take the continuous load at 125% and the non-continuous loads taken at 100%. And then if you drop down to A2, you'll see that it's separate and it doesn't mention anything about the continuous and non-continuous load. It just says the adjustment and correction factor. So therefore, you're doing it at 100% of the load. And that's where all these changes took place because there was misapplication of how to take and apply the percentages. So like you were saying in the open statement, if everything's non-continuous, you can take it right up to 100%, okay, for 20 amps. But when you get into continuous loads and everything, once you put the 125% on, that's the same as the 80% of the breaker. Now, you can have a breaker that is rated at 100% duty and take continuous loads and everything all the way up to 20 amps if it's rated as such.
Yeah, and I will add another thing to that, that basically we ran into with the comments where they say the ambient temperature comes into factor. And there's, if that ambient temperature is only 10% of the run, then you do not have to factor it in. So there's a lot of these code guys out there that'll sit there and throw up this ambient temperature and say that you're going through a attic in Florida. And there's a lot of assumptions out there with the code world. And so you just have to understand, a lot of times I do commercial. So I look at that stuff. And a lot of times we have underground PVC that goes from the panel underground to an AC unit. And that conduit might be exposed to direct sunlight for maybe, let's just say 10 foot. Well, that's a 200-foot run of PVC, so you don't have to factor in the ambient temperature. In that case, that 10 foot is less than 10% of the run, and you do not have to factor in ambient temperature in that case.
That's right.
So it's just something to add in. We might have to do that for a minute too. Maybe try to teach some of these code teachers how to, present their material better, and
I actually have that in illustrated form showing how to do that calculation. So
nice.
I might have to roll that next week or something.
We might have to do a topic on the tap rules too, because that seems to be confusing some people too.
Yeah, when you were talking about that, from the question last week, and we had 150 amp coming off of that tap, and I said the upstream was 450, and then I think it was Eric Collier or somebody was saying, no, it can be larger than that. No, it can't. And let me explain. If I had a 600 amp upstream and I take that at a third, that's 200 amps. So the minimum size that I could have off of that tap is 200 amps. And I could go all the way up to 600 amps. Once I got up to 600 amps, and if I tapped a 600 amp off of 600 amp, it's no longer a tap. It's just part of the feeder. Okay.
Right.
And when you were telling me that, I said, just ask them that question. Well, it probably went silent at that point because the argument they were making didn't hold water at that point.
Well, the thing that was funny about it was I kind of did that whole question reverse, and it was kind of interesting to do it reverse like that. But at the same time, it was kind of funny. I kind of almost confused myself in the whole process. But at the same time, it was almost funny because I put 150 in was one of the answers, and then they said that's the answer is 150 because that was the minimum or whatever, you know. But it wasn't the minimum, you know. It was really confusing. It was nothing really. You couldn't really change the numbers for that question. You know what I mean? You would have to write a whole new question to change the numbers and change everything, you know. And I was trying to kind of stick with that same question and do like hypotheticals, and I think that's where I get kind of off base. And I gotta watch it, you know. I realized it. I was like, all right, I kind of, you know, got a little out of control on that one.
Well, the way the question was written when I answered it, it was correct. It was 450 when I read it, and then when you told me what was going on, I said, just ask them this. That should end the debate.
I went and edited the question to minimum because somebody said there's no maximum, and then I was like, well, I thought there was no maximum, and then they're like, oh, you just said there's no maximum, and I was like, you know, it was I got a lot of things taken out of context with that, but it is what it is. It was fun, you know. Like, I do this for fun. I don't do this to try to make anybody look stupid or try to call anybody dummies or anything like that, even though you're in the NEC for Dummies. But, you know, the whole thing is I really like the NEC for Dummies because I'm fine. I'll be the biggest dummy in there. That's fine. You know, I mean, I'm learning every day. A lot of the guys, like me and James, we were in a podcast with your dad, and we were just like, our jaws were just dropped, all the stuff we were learning. You know what I mean? Like, he's just teaching us so much about the multipliers and how they came up with the table, how they came up with table 25066, and, you know, what it was based off of, and when they moved the made electrodes over and why and all that stuff. And it was just a lot of learning that took place, and it opened our eyes that there's a lot of people out there that don't want to learn. They don't want to learn new tricks. They just want to say what's already in there is right and you're wrong and whatever, and that's fine. You're entitled to your opinion, and, you know, we're not gonna say your opinion's wrong. You know, we're just here to have fun and enjoy our time, and you know, like I say, we have some really intelligent people in here. We have IEI members that pop in from time to time and stuff like that, and you know, actually we have some inspectors that pop in from time to time, and it's really awesome that they're able to contribute. And there's a lot of them that don't agree with us, and I don't care. You know,
Right.
it's like, oh, you don't agree with us? Cool, that's fine.
Right.
But you know, like I didn't even cheat, and I didn't even check what your topic was this week, James. I almost never know what your topic is, but I always look forward to.
I'm doing arc flash risk assessment, and I'm going to do it again next week because it's going to be a 2-part. There's a lot that's in here, and I don't have time to go through everything in one night. It'll take me 2 podcasts. But next week, I'll go through the tables and everything and explain and all that as it ties into what's required as part of the arc flash risk assessment. So
Nice.
let me go ahead and get the topic going, and then I'll start explaining everything. All right. Now, looking at the topic this week, what we're going to look at is the first part of the arc flash risk assessment. And this is going to be over in 130.5 of the NFPA 70E document. And I'm just going to go through the steps first, basically. And I'm also going to tie this in to what is considered that I did 2 weeks ago for normal operation and abnormal operation, because that table is going to come into play here also, table
Okay.
130.5G. But I'm going to go through and I'm going to explain everything down to a point, and then next week we'll get in more intricate parts of it where we're looking at the table, and I'm going to have to blow different parts up and stuff because the tables are so big. But I'll get
Okay.
in and talk about the parameters and all this other stuff that's in there.
Well, and just a shout out, if you guys like the content we're throwing out here, don't forget to like, subscribe, and just give us some love. But I'll let you keep going.
Okay, now as I look at this stuff and you get into the general requirements for what your arc flash risk assessment is, the things that you're going to look at first and foremost is to look at identifying the arc flash hazards. And then you have to estimate what the likelihood of occurrence of injury or damage to health and the potential severity of injury or damage to health. And then to determine if additional protective measures are required, including the use of PPE. And I'll get into all that here in a little bit. I gave some examples last week, but uh, when I was looking at shock protection, but I'm going to talk about different things you're going to look at. And then next week, when I get into this, we'll start getting in to looking at the selection of the PPE and stuff based on the tables. And also, if I'm doing the calculation method, I'll show you the tables for that where you go in and do the selection. And
Yeah, and just to not interrupt you, but basically just to highlight this a little bit, this was pretty much my one major complaint with some of these YouTube guys saying that we were working in electrically unsafe work conditions. So that's our job as electricians, is establish electrically safe work condition, and then what you're gonna do is you're gonna do a risk control on all these things that are mentioned here. So I think that's the first step you have to go to when you're trying to comply with 70E.
sure.
So sorry to interrupt you, but
Oh, no worries. But we'll get into looking at all that next week. But right now, you just have to understand that you need to identify what these hazards are. If there's any additional protective measures that you're going to have to take, and then also selecting the PPE, and then looking at the likelihood of occurrence. That's where we're going to get in and start looking at abnormal operations and where you're permitted, or I don't say permitted, where you're going to be working on it, energized, and looking at that table for the different type of tasks that you'll be performing. Okay. So
okay.
when I look at B, this gets into the estimate of likelihood and severity. That's number two that I just looked at. And it says when you're looking at the estimate of the likelihood of occurrence of injury or damage to health and the potential severity of injury or damage to health, shall take into consideration the following. And it's going to tell you what is the design of the electrical equipment, including its overcurrent device and its operating time, and the electrical equipment operating condition and condition of maintenance. Now, let me explain a little something here. And this is going to be important for next week. When I get in and I start looking at making my selections, and this doesn't matter if I'm using tables 130.7 C15A through B and really C because that's a selection, or I'm looking over an Annex D and I'm doing the calculation method. There's certain information that you're going to have in order to make these assumptions. Okay,
Yeah,
and
and that was the one thing I really liked about what you did when you're analyzing that picture in that video, was that there was no clearing time of the overcurrent device factored in. There was there was a lot of things that weren't factored in. When you get into these assumptions, it kind of is a little bit dangerous because you're just sitting there going in assuming that somebody's working on an energized circuit. I'll tell you what, honestly, if you guys ever see me working on 4160 energized without being suited up,
Yeah.
I'm probably not going to be talking to you anyway. I'm not going to walk out of there. You know what I mean? Like that would be the silliest thing anyone could ever do, especially if one of those motors ramped up, all those covers are off when you're over there with no PPE on. I would not want anyone to be in that kind of situation.
Sure. And there's a lot of things that you look at when you start getting into all this stuff, and you literally have to know exactly what you're looking for when you make these determinations. And one of the things that I always tell people when you're getting into this is always look at the front and what are the requirements, because there's certain information that you're going to want to know. And one of the most important things to know is what is the clearing time of the overcurrent protection device. That is probably one of the most important things that a lot of people don't really look at. And I never understood why they didn't, because, they go in and they start learning all this stuff about safety and all of this, but there's certain stuff you have to look at in order to make these determinations. So like when you get in and you look at an example calculation at the back, and you look in Annex D and you're making assumptions for sizing, let's just say you're doing an arc in open air, okay? There's certain information.
Oh yeah, we learned that from Mike Barr. Big shout out to Mike Barr. I never knew that before.
Sure. And
there's a whole different table on open air arc versus inside equipment.
Sure. And there's three pieces of information when you get back here, and it doesn't matter if you're doing an arc in open air or arc in a cubic box. You're going to go back there and you're going to look at D.32, and I think it's 3.3 if I'm not mistaken in the 2021. Right. And what you're going to have to know is, like, what is the distance you're going to be away from it in front of it? Well, the typical is 18 inches. Basically, that's arm length, okay? And that's where you're going to maybe flip a breaker off or something like that. But that's 18 inches. And then there's two other things that you need to know. You need to know what the arc duration is. What's the clearing time of that overcurrent device in seconds? And then the other thing you're going to need to know is what is the short circuit current rate, okay? Now,
and you run into, when you look at the clearing time, there could be a massive difference between some of these overcurrent devices clearing in maybe a quarter cycle versus one would clear at a quarter cycle and one would clear at 3 cycles.
That's right.
You're going to have a whole bunch of different incident energy in there, and I was really amazed with Mike Barr because he taught me a lot about that, because they're only required to have 2 cal to go energize a 80,000 volt switch.
Mm-hmm.
They're only required to have a 2 cal.
That's right.
And they don't even need to have hot gloves on their, to me, I was like, wow. I mean, because the likelihood of injury is very low.
That's right. And that's what you get into when you're looking at this. And that's why I'm saying, that's why it's a 2-parter for this, because when you get in and you start looking, it doesn't matter if I'm doing the calculation method in Annex D to determine what my cal rating is, or if I'm using the table value. Even in the parameters, when I'm using the table value, there's 2 values you got to know. You got to know what the available fault current is, or short circuit current, whatever you want to call it, and you need to know the clearing time. And if you do not meet those minimum parameters that are in there, you can't even use the table at all. You're going to have to go to the calculation method, okay? And I'm going to show that next week. But the point behind this is how you're determining the estimate of likelihood and severity. Now, let me point one other thing out here. in that B2, it also talks about the operating condition of the electrical equipment and how that equipment has been maintained. If the equipment hasn't been maintained properly, that can also change the severity and likelihood. Okay?
Yeah,
So
and I agree with that. Like for all the apprentices out there, if you see a bunch of like weird things going on with the gear when you're getting ready to open it, maybe burn marks, like and like Lemonhead told me one time he ran into a glowing screw.
oh
The
yeah,
screw was glowing. He's like, I'm not touching that glowing screw. You
hell
know,
no
that
you
kind of
don't.
stuff that's a likelihood of injury right there. If you see a glowing screw,
That's
you
right.
call the utility and have them get it put into electrically safe work condition for you.
That right there falls under the electrical equipment operating condition. It's not operating properly.
10-4. I
All right.
agree. Abnormal.
Now, look at this. Then you go to C, and it talks about additional protective measures, and it tells you they're required and they shall be selected and implemented according to the hierarchy of risk control identified in 110.5H3. And I can go back and do that on another one and come back and tie this in. That's why I say it's going to take me two of these to do it, because there's so much back and forth.
Yeah.
But it says, when the additional protective measures include the use of PPE, the following shall be determined. You got to know the appropriate safety related work practices, the arc flash boundary, the PPE to be used within the arc flash boundary, and then looky here. And I said this a while ago, when you're looking at the estimate of likely of occurrence, and we looked at this last week, I said, or 2 weeks ago when we were talking about normal and abnormal conditions, I said you're going to look at table 130.5C, and this is going to tell you the type of installations where you're going to work on it while it's energized in an abnormal condition. Okay? So this is tying into what I talked about 2 weeks ago. Now,
it has to be justified energized work too through the other.
Well, sure.
Because a lot of people don't realize that if you can't do a scheduled shutdown on that, then you have to justify why you can't do that scheduled shutdown.
Sure, that's right. But at least they have items that are listed in place for that, if you can.
I agree.
Now, let's look at C1 first, appropriate safety-related work practices. If you remember last week, I was talking about the shock protection boundary, and I talked about the limited approach boundary, and I said sometimes you have a safety backup when somebody's working inside that limited approach boundary, but let's just say they're inside the arc flash boundary, okay? Mm-hmm. Now, if something happens to that person while they're in there, how are you going to handle this? Well, I may have a disconnect and say the disconnect is inside that boundary. Then what I'd want to have is a non-conductive pole. If something happens, I can take that non-conductive pole and hit the handle of that disconnect and turn it off. Okay?
Okay.
Maybe I have a non-conductive rope in there. If something happens, I have it tied around his waist. And if an arc does occur, knocks him back, I can grab that rope. I'm outside the arc flash boundary, the limited approach boundary, all that. Then I can pull him out of there. You see what I'm saying? You never.
Yeah, and that's part of your rescue plan with OSHA too. You know, so you're kind of have to comply with OSHA as far as with this electrical safety, and you have to have a rescue plan.
Sure, and that's what I'm saying. All of that goes into part when you're taking and you're doing your energized electrical work permit, and you're writing those additional safety measures in. You always have to look and see what's there and what you need to do to protect yourself. Okay?
Yep.
And then the arc flash boundary, I will get into all that next week, and the PPE to be used. We'll go in and we'll start selecting all this stuff next week. But what I'm trying to point out here, this is the path that we're following in order to make the assumptions, in order for us to do our selection, not only as it applies to the PPE and the arc flash boundary, but any additional safety measures that we need. And I also tied that in from last week where we also did the shock risk assessment. Okay,
Right.
so you're noticing I'm doing two different. In 3 weeks I've done 3 different things here in order to show how do we do the assessments and everything here to determine what I need to protect myself and any additional safety measures when I'm out in the field as part of that energized electrical work permit.
Yeah, and I will actually admit something. It was kind of my fault with the whole thing because I posted on one of the 70E groups and I'm like, hey, we got our medium voltage tester guy and, he's not cheap. And so that was Lemonhead. He was my guinea pig. So
Cool.
I kind of threw him out there. So it's weird. I just couldn't believe that somebody who's educated in electrical would actually believe that we were working on 4160 energized. That's just, I would never do it, but.
All right, now we looked at this 2 weeks ago and we looked at table 130.5C as part of abnormal conditions. And this is where you get into the estimate of the likelihood of occurrence again. There's that same terminology of an arc flash incident for AC and DC systems. And then you come in and you got these different tasks. I'll give you an example of one here. It says the second one, performing infrared thermography and other non-contact inspections outside of the restricted approach boundary. This activity does not include opening of doors and covers. Now, let me give you an example. When we first started doing this, and I would be out teaching this, somebody would say, well, what if I'm doing a scan on a transformer, the transformer could be up in the ceiling. I don't have clearances and stuff up there. And I said, that's perfectly fine. What you need to do is go upstream, turn it off, and lock and tag it out, and then go make sure everything's de-energized, test the meter, test circuit, test the meter again. And then you need to set stuff up to where you got that protection from anything that could create a touch and step potential. And I said, Then once that happens, then you can go up there and then turn it back on. You've got all your protection techniques in, and now you can take and do that thermography scan on that transformer. Because if you look before, how many places have you seen where they'll have a transformer, they've got it hanging off some all thread and stuff coming down, and you don't have clearances up there? I've seen that in a lot of different installations, older installations, but they still use that transformer and they need to check it periodically. Well, if that's...
Hey, we had a really good question come in real quick, James. Maybe you can field this one. Really good question. Thanks for joining us, Nicholas. Appreciate you jumping in tonight.
Okay, let me answer that for you. Now, what happened is when we put the tables in, basically, we put that in there. That was mainly for contractors. You go to big facilities, they're taking and they're performing all their arc flash calculations and everything for all their equipment and all that. And, I actually went out and I was out at Nucor Steel in Seattle, and they had me come out. They had actually come to one of the NFPA classes that I was doing on 70E, and I told them some of the software that was being used at that time wasn't taking into consideration some of the parameters that were in the tables, and therefore some of the things that they were coming in and doing a hazard risk category on some of that equipment was wrong. And they said, well, they had me come out, and right away I could go down and just see what the parameters were, and I'd say wrong, 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 and they were like, well, what am I going to do? I said, well, what you need to do is you've already calculated everything based on the cal. Just set everything up based on what that cal is and forget those hazard risk categories. And
well, wasn't that the one where they were just boilerplate going off the available fault current for like the primary overcurrent device?
No, they were doing it all the way down through their separate drive systems and everything.
Okay.
Now, when all that happened, what we realized after we put it in, what we realized is that the contractors and everybody, it was like pulling your teeth out to try to get the available fault current from the utilities. So what happened in the next cycle, we had proposals that went in and it was added in 110.24A and B, and it talked about the available fault current. So now when you go out on a new job, you get that available fault current from the utilities and you have it upstream at that point. And then we also said if it gets modified, which you'll see here in a little bit, we're going to look at labeling and stuff. And after 5 years, it has to be re-looked at anyway in case something was added through the building or anything, and put the new available fault current in there if it has changed. Okay, so
true. And
you've got to have that. You've got to have that available fault current at the equipment, or you're going to have problems applying the tables that are in there. And if that's the case, then probably the best thing to do at that time was at Nicholas or whoever it was. Now you're going to have to look at doing the calculation in Annex D and get your available fault current.
Yeah, and I do hear people say that they're not able to get the available fault current, but I think Buzzman has an app that you can go in and you can put in the length of the circuit, you can put in the circuit size, you can put in the whatever brand overcurrent protection device you have, and then you'll get that available fault current. So great question, Nicholas. I appreciate you bringing that.
Yeah, you always have to evaluate the fault current. If you don't know that, then you don't know what you're going to need that available fault current. You're going to need the clearing time in order to use the tables, and you can't exceed the parameters that are listed underneath the table. If you do that, then all of a sudden the table is no longer valid. And we're going to look at that next week. We're going to go more in depth on that. And I'm actually going to make up a problem and go through it and show you how you do it both ways. Okay. And that's going to be easy because we already have it in our 70E publication, which I will tell you, y'all want a good publication, that's the one to get on 70E. And I can tell you, it's the first one that was ever put out. And it not only has 70E, it also is in correlation with the National Electrical Code and also the OSHA standards. And also 70B when it deals with maintenance also.
Yeah, I noticed your dad was starting to get into 70B. I was like, oh, we created an animal.
Oh, yeah. Now, look at this. If you look at D, all of this has to be documented. Last week, when I was looking at the shock protection boundary, did it also have to be documented? Sure. And that's part of doing an energized electrical work permit, or you could have just, if you're a facility, you could have an energized electrical work procedure for that equipment. Okay? Either way will work, but if you're a contractor coming into a facility, what you're going to do, you're going to do an energized electrical work permit, and not only will the facility sign off on it, but you sign off on it also, and that sort of provides the documentation that everybody's aware of any of the hazards they may have exposure to. All right?
Nice. I like
now,
that.
If you look at the arc flash boundary here, now it says the arc flash boundary shall be the distance at which the incident energy equals 1.2 cal centimeter square. Anything over that is going to change everything, but up to 1.2 cal, that is considered a curable burn. Okay? If I calculate that, I'd probably put on maybe 3 cal just to make sure I didn't even get a second degree burn. But that's based on a second degree burn. And if you look at the informational note, it tells you when you're determining that arc flash boundary, which annex do I go to? Looky there, Annex D. And that's why I said you pick up 3.32 and 3.33, okay? Now, looky here. Also, the arc flash boundary shall be permitted to be determined by what? Table 130.7 C15A or B. All right? It's already given to you in there if you meet all the parameters and everything that's in that table. Okay?
Hey, didn't we come up with something from Mike Barr on that 1.2 cal thing where they just round up to like 2 cal, or wasn't there something controversial? Not really controversial, but there was something they said about the cal rating, and then the actual standard was 1.2 was the minimum, and then
The utilities, they never changed it. It was 2 when it started out, and then it went down to 1.2, but the utilities are still at a 2.
Okay, yeah. And so these guys, which blew me away, and really thank you a lot, Mike Barr. You taught me a lot about the utility side. They're going up there and they're hitting those chicken switches with 80,000 volts, with 2 cal on.
Yeah,
They're dressing in 2 cal with no hot gloves on their hot stick, because as long as their hot stick is maintained and free of oil and dust, and everything's in good shape, you could do it barehanded. And everyone's like, oh, that's not smart. But the whole thing is, it's like there's really no difference between barehanded or the hot gloves if your hot stick is in good shape and everything, and you're doing that right.
Sure.
So
that
was really interesting.
I'll make another point on this. I actually represent a company that we did some work for, and OSHA come out. I'm not going to say the guy's name because I still have a lot of respect for him, but he come in and told them that they had to use the tables. They could not take and use the cal rating. And I said, no, that's not correct. They called me. The attorney they hired, this attorney is how we actually got into all of this. And the other day I made a post that we're on the big attorney network now as experts on the NEC and NFPA and OSHA standards and everything, as expert to use that is recommended now in these cases like this. Well, we went up against OSHA, and I wrote a report, and I said, no, actually the table value is the second option. The first option is being able to take and use the cal rating, arc flash boundary, and everything that's calculated in Annex D. And if you look here, E1 is the first one that's listed. E2 is the second one, which is the tables. Well, right before that, I was supposed to go and get a depot. I was just leaving for the airport, and I get a call, and they said, okay, don't worry about coming. They dropped the case. Well, the reason they dropped, because everything's laid out here, and this is explaining that this is your first option. Okay?
Right.
And that's why I pull it out. And next week, when I do the final on this, I'm actually going to do the calculated portion first. Then I'll do the selection method of the tables as the next part.
Nice.
Now, look at this. Arc flash PPE, it says one of the following methods shall be used in selection of PPE. Now, you have the incident energy analysis method. Now, that's going to be, and we're going to look at this next week, that's table 130.5G. That is where I'm doing the calculation per Annex D. And the second method is the category method, that is where? In tables 130.7, C15, A, and B. And that's where you're working on it. And C is where you select the PPE. Okay?
Gotcha.
And then it tells you either, but not both, methods shall be permitted to be used on the same piece of equipment. So you can use either one. We don't care which one, but it says the results of an instant energy analysis to specify an arc flash PPE category in the table, guess what? Is not permitted. And that's why the reason that is because we have certain tasks and stuff. We built a lot of extra safety in there, I guess you could say. And basically, when you go over and look at that, it's based on certain parameters. And that's why you can't take and use the calculation method, because you're not meeting those parameters in the extra safety that we built into those tables.
True. And one thing I want to ask, based on Nicholas's question.
Mm-hmm.
So, and this is a really good question, but like, let's just say, is there a way that the evaluation of the total available fault current could change based on the clearing time of that equipment that you're working on while energized?
Hell yeah, I can. The quicker the clearing time is, the there's not going to be as much duration there. Therefore, the arc's going to clear quicker, and it's going to take, and your exposure to a higher arc rating won't be available. Now, I'll tell you something that a lot of facilities have done over the years. Some of them, they go straight to the service and they do one calculation of the highest available fault current in the facility and what the clearing time is, and they wear that PPE from that point on.
Yeah, and I mean, there's really nothing wrong with exceeding the safety standard.
There's not.
What you really have to worry about is exceeding the belt buckle size when you're in Texas, because you can't go too big of a belt buckle in Texas, or else it just gets excessive. But I'm just joking with you, but all right, I'll let you continue.
All right. Now, when you get in, you look at G, this ties in with table 130.5G, and this is the incident energy analysis method. Okay. I'm not going to go through and read all this, but basically what it's telling you here is that this incident energy exposure level shall be based on what? The working distance of the employee's face and chest area from a prospective arc source for the specific task to be performed. And that's what I was saying. Most of the time you're interacting with it and they just do an arm's length, and that's 18 inches. Okay. The majority of it's going to be calculated, but let's say you're racking something in and out. Now that racking in before it makes connection back there could be 24 inches. You see what I'm saying?
True.
It depends where that distance is and where that contact's being made, and that can change the way that this set up. But now you got to look at it this way. If I'm racking something in and out, that's considered like arc in a box at that point. Now you're going to be using the other calculation instead of free air, where if I was operating an overcurrent device or something with my hand, that's considered free air right there. You see what I'm saying?
Well,
it depends on the type of installation to which calculation you're going to use.
And you remember the one that me and Lemonhead did out at the plant? That was a rear feed equipment.
Mm-hmm.
And there's a whole separate thing for rear feed. And that's what this individual that made this video saying that we're working on an electrically unsafe work condition, that was the claim that he made, was that working clearance is actually extended further when you have a rear feed equipment. And there was a lot of assumptions made, and that's where you have to know what you're talking about when you go out there on YouTube and start talking about this stuff.
Well, that was Ryan. And Ryan did. I'm just going to tell you right now, he didn't have any clue what he was saying. I mean, when he sat there and he said that you take and use table 110.2681, or was it 34A, whatever he was saying, he said that's your arc flash boundary distance. I told him, I said, you don't know what you're talking about. I said, that's working clearance, has nothing to do with the limit approach boundary, restricted, or arc flash boundary. I said, it's a total different thing. And then, of course, there was no comment on that. But,
Well, the reason I took that picture was because I thought it was a major code violation. And so I was sitting there talking with the 70E teacher, who was the third-party tester out on the site, and he goes, that ain't no code violation. And I was like, what do you mean? He's like, you gonna go take those covers off without being suited up? And I was like, well, probably not. I was like, I know I'm gonna get sucked in there if that motor ramps up, But I was like, I don't even want to be in this building if that stuff's energized,
Sure.
Honestly. But it was funny, and so he used our picture as his little training, so I thought that was cool.
Now, I want to drop down to the second part here. Now, look at this. It talks about the incident energy analysis, and look what it says. It shall take into consideration the characteristics of the overcurrent device, and look at this, its fault clearing time and its condition of maintenance. Okay? Now, I'm going to tell you, even though I'm doing the calculation method here, you're still going to have to do that when you're looking at using the table method. Okay, and we'll get into that. Then look what it says here. The incident energy analysis shall be updated whenever changes occur in the electrical distribution system that could affect the results of the analysis, and this incident energy analysis shall also be reviewed for at accuracy at intervals not to exceed 5 years. And then the next one after that says, when you're selecting and identifying your arc-rated clothing and other PPE requirements, look what table it tells you to go to. Table 130.5G when you're doing the calculation method. Okay?
Right.
Now, after I get through that, then you look at the equipment labeling. Now, you're going to see in 110.16 of the National Electrical Code pretty much identical, word for word, the very first part of this. Electrical equipment, such as switchboards, panel boards, industrial control panels, meter socket enclosures, and motor control centers that are in other than dwelling units and that are likely to require what? Examination, adjustment, service, or maintenance while energized shall be marked with a label containing the following information. Now, when you go look at 110.16, it says you have to identify that an arc flash hazard is present, right?
Yeah, yeah.
Okay, that's the difference. But now look at what we require here in the 70E document. We want to know what is the system voltage. We want to know what the arc flash boundary is, and then you need to put in one of the following here. You need to have the available incident energy and the corresponding working distance. Okay, well, if I look at the available incident energy, that's going to be in compliance looking at 110.24A and B of the National Electrical Code, which is going to get into your short circuit current or available fault current, whatever you want to call it, and then you need the working distance. Or it says I can use what? The arc flash PPE category, that is in 130.7C15A or B for the equipment, but not both. Or I can have the minimum arc rating of the clothing or the site-specific level of PPE. You got to have one of those following. Now, is there anything else you might want to put on that label that's not listed? Because you can always go above and beyond that. Well, I may look at this.
I would put where all these devices are located in the property, so you know where to go to actually isolate this to make it an electrically safe work condition.
I've never seen that, but what I have seen, when they want to put additional information, they may come in and put like the restricted approach boundary, the limit approach boundary as extra information that's on there. They also will take and put what the working clearance is to be around that equipment to make sure that they're meeting what the code says.
For example, I've seen it where we're working on a UPS and there was 2 power sources. So you know that this equipment's fed by 2 power sources. So to establish an electrically safe work condition, you have to isolate both power sources. You can't just isolate one power source and dive in there. That's kind of what I was meaning by that.
Yeah, well, we also have that listed in the 70 standard. If there's 2 power sources there, you have to identify that with labeling on the equipment. That has to be on there to let people know. Okay?
Nice.
But I'm just looking at some additional information that could be on here. Maybe you want to say you have a safety backup, and maybe you have a non-conductive pole, you're using a non-conductive rope. I mean, there's all kinds of things that we could put in here as additional information that could be part of that equipment labeling. But for now, this is the very minimum that you need on here. Okay? Now, they have some exceptions here that they look at, and exception 1 says, unless changes in the electrical distribution system or systems render the label inaccurate, labels applied prior to the effective date of this edition of the standard shall be acceptable if they complied with the requirements for equipment labeling in the standard in effect at the time the labels were applied. So they're going to allow those labels to stay on there. But the way I look at this, that becomes a problem, especially after 5 years, because you need to go in and look at it anyway. And if it has changed, now you need to bring that labeling up to whatever the new changes are. Now, exception 2 gets into supervised industrial installations. And of course, when you're in a supervised location, this is where you have conditions of maintenance and engineering supervision that ensure that only qualified persons monitor and service the system. Now, when that happens, all of that information is required at this, or let me put it shall be permitted to be documented in a manner that is readily available to who? The qualified person that is going to perform the examination, service, and maintenance of the equipment. All right. Now, they drop down right after that, and this is what they tell you. The method of calculating and the data to support the information for the label shall be documented. The data shall be reviewed for accuracy at intervals not to exceed 5 years again, which is what I was talking about in exception 1. And then it says where the review of the data identifies a change that renders the label inaccurate, the label has to be what? Updated.
Yep.
And of course, and this is where a lot of companies, they don't realize and they don't do their safety, but it is the owner of the electrical equipment that's responsible for the documentation, installation, and maintenance of the marked label.
Right.
Okay.
That's 100%.
And that is going to get us started when we get ready next week, and I start laying this out and showing you the tables and everything.
Dude, awesome presentation, sir. I appreciated it. I learned a lot. I learn every time we do these. That's why I do it. I learn, and I hope everyone else learns. It's awesome.
Well, just luckily, I've been on the 70 committee pretty much since it started, so I've heard every argument that's come in, why we did what we did, and all that. And that's why I'm so detailed with it, because I've been teaching it for NFPA for since they started teaching it, and when I was out there and it was in its infancy, I was getting all kinds of damn questions I had to think about, because it was new to everybody. And as being one of the first instructors out there that was teaching this stuff, and you're having all these facilities come in. I remember I went to Houston and we had the oil and gas industry, all these people come in. I almost had 250 people in a freaking auditorium when we first started doing the safety. And I went out there 3 times that year, and every one of them were 200 plus in the auditorium.
Wow.
Trying to learn what the requirements were.
Well, and what's so awesome about that is I really feel electrical safety starts with knowledge.
It does.
Like, I really feel electrical safety is not like, well, you better have a 40 cal suit on if you open up that J box. To me, that's ignorance. That's stubbornness. That's stubbornness to understand the code and know that. How are you going to know that J box has energized electrical equipment in there?
Mm-hmm.
Now, I agree with you. If it has exposed energized parts, then we got to be suited up. We got to select our PPE, everything like that. But when you have insulated conductors and you say, well, what if somebody pinched that cover, whatever, we're not a what if code. We've never been a what if code. And we can't do that. We can't have that approach.
Well, when you have a barrier put in place, that's to protect you. And that's keeping you from, and it's no different than having a cover on a panel board. There's a reason that the barrier's there. And it's an additional means, additional measures that were taken to provide protection from energized parts.
I agree. And you're protecting the workers. So
that's right.
But you still have to look at the likelihood. Like, if you have exposed energized parts, it doesn't matter if they're around the corner and to the left or whatever. It's still a likelihood of
occurrence. We call it likelihood of occurrence. You always have to look at. That's why the language is written the way it is, because we realize you got to take into consideration the risk and what is the likelihood of occurrence. And if it's there, you need to protect yourself. I mean, that's how it works.
I agree. I'm just
that's
glad all my apprentices don't throw me under the bus for this, but
that's why I always tell
I always
everybody.
try to keep everyone safe on my jobs.
It's like I always say, and I don't beat around the bush about this. If you have exposure to energized parts, the 70E committee, we don't care who you are. You got to protect yourself, period. And that's why you don't see us calling out specific people or anything. It's a generality for anybody that has exposure to it. Okay?
I agree.
All right, you ready for your tool?
Yeah.
I think we beat that in the death, didn't we?
Yeah, it's all good. Everyone
Until
learn.
next week.
Yep.
Here we go.
It's time for Tool Review of the Week. Sponsored by Electricians Only Tool Review and Nipex Tradesman.
All right. Well, I have a really great tool review for you guys this week. This one is actually one of my favorite ones of all time. This is just basically a MIlwaukee compact drill. I think it's 12 volt. Like I say, I would actually recommend this for like trimming out devices. This is not like an impact where you're gonna strip the screws out or anything. You can set the clutch. I really like this for trimming out devices. It's real light. It fits in your pouch. This is one of my favorite tools MIlwaukee makes. And I wanted to do a review on it because if I actually was going to go out and buy a tool that was red, then I would go buy this one just for trimming out devices, making the screws go in fast. You could put it in your pouch. It's light. It's not heavy. And everyone knows I'm a DeWalt guy. The DeWalt tools are really heavy. I mean, almost every single one I call them the wrench. Like I have the wrench sawzall, the wrench drill. I mean, they'll rip your hip off if you put them on your belt because they're so heavy. But this thing is really light. It's really compact. The battery's charge in I think about 20-25 minutes. So that's really cool that I thought about when I was doing this review. And it's real easy to use. All your tips just click right in there and you're ready to go. Honestly, that's one of my favorite MIlwaukee tools out there, and I recommend my apprentices go out there and get one of these, and like I say, really rips it up. Looks like we have another comment came in. So Jason, haven't seen you
brother.
Before.
It's going to be next. You need to watch next week because I'm going to go in more detail with the tables and the calculation method showing how to do all that, and then using the tables for all the selection method and everything. And I think the last 4 weeks, this will be a full month that goes through and sort of explaining all that, and hopefully you'll have a better understanding of how to use the 70 document.
Yeah, Jason, if you go over to the Volt Online Academy YouTube channel, we're breaking out the topics, so you don't have to watch the whole show. We're trying to do it to where we produce these live and we break out a whole bunch of different topics, and then what we do is we chop them down, and then if you want to watch the tool review, you can watch the tool review. If you want to watch the topic, you watch the topic. If you want to watch the myth of the week, you watch the myth of the week, and kind of chop it down. And one of our segments that we're really proud of, Jason, is the code question of the week, where I actually ask a code question. I try to stump the master, James Stallcup, live, and I just put these slides in there. And so let's see if we can stump the master, James Stallcup.
He's having a hard time doing it, Jason.
But I am.
Jason, I will tell you, if you go to the Vote Online Academy YouTube channel, we're slowly but surely breaking all the videos down and everything. There's over 260, 70 of them right now. But by the time first year gets here, there's probably going to be over 500 videos on there. And I don't even know how many's actually subscribed. I don't pay attention, but I do know that it keeps popping up all the time, all the people that are watching the videos. And there's so many hours and hours and hours of people watching the content that we're providing. And if you have any comments on something, just comment, let us know, and I'll try to guide you in the right direction, brother.
Oh, we have David Englehart. Awesome, David. Thanks for joining us tonight.
Hey, David.
Appreciate David. Awesome having him in the chat.
All right.
Tonight.
Let's see what your question of the week is here. All right.
And just so everyone knows, ChatGTP got it wrong. ChatGTP has never got it. Rarely got one of these right.
Ask another. Oh, it's if you have non-linear loads and those, that's, what is that? 130. Well, they changed it. Used to be 130 point. I'm sorry, 210.15. B4C, I think it was.
Yeah.
But when you have those non-linear loads and stuff and harmonic loads, that becomes a current carrying conductor. One is where you in a lot of electricians, especially first ones, when they're looking at this and they're looking at the grounded conductor, they don't really understand about unbalanced current and all that. And that's why we spend a lot of time when you get into grounding in Article 250, we break all that down and explain what the unbalanced currents and stuff are. But my answer is A, by the way.
So you're locking in answer A?
Yeah.
You nailed it. And guess what? The whole reason you nailed it, I knew you'd get it, but the whole reason you nailed it was because when you look at that unbalanced current, you could have, let's just say, two circuits. Like, let's just say you have a 30 amp washer circuit or a 30 amp dryer circuit in your dwelling unit, and you bring a neutral there because the code says you have to bring a neutral there. You're maybe only looking at maybe a tenth of an amp of unbalanced current,
That's right.
So it's not like...
Yeah, we actually
David nailed it too. You got it, David.
That was an easy one. Matter of fact, we actually go in and show you how to take all the different phases and determine the unbalanced current through the phases and everything with the neutral. So
just a shout out to you, David. I put an easy Willie quiz in tonight. You should get every single one right tonight. So it's an easy quiz tonight. So.
All right, let me run it. Let's get it going.
So I would give David advice this week. Just copy James's answers because he's 2-12 so far. So.
Yeah.
All right. So what percentage of electrical injuries, and these are non-fatal, so these are non-fatal injuries. So I think I don't want you to get confused, James, because I know we already did fatal ones. This is non-fatal, but what percentage of those non-fatal electrical injuries were due to direct contact with energized equipment? Would it be A, 70%, B, 75%, C, 85%, D, 90%, or E, 100%? And I really think that this is like the easiest question I probably ever give you or anybody in the chat. So good luck, everybody, and hope you like it. You got the tune? Where's the tune?
God, yeah. I'm sorry. I was sitting there looking at things. Sorry about that. Okay. I got
All right, we have an answer from David Englehart. He is locked in at 90%.
I've got one question.
David Englehart is going with D. Great answer, David. What's your one question?
This has nothing to do with fatal, and these are reported injuries, right?
Yes, reported non-fatal.
Non-fatal that were reported. I'm gonna say 70%.
All right, so if David is correct and you are correct, then you guys would have a correct answer in Willie Trivia. So now, let's just eliminate those two answers. Out of the ones that are left between 75, 85, and 100, what would you go? What would be your second answer?
So neither one of those were right.
Nope. And like David's not good at trivia, but James is kind of good at trivia. I try to make this one easy because it was, you just have to know the statistics.
Well, I guess it'd be 100% then.
All right. Well, so if you were to go to choose from the two options that was left between,
I guess 75, because I thought it was on the low end at first, but the way you wrote the question, it's sort of hard to understand it.
All right. Well, it's kind of my fault that it was really hard to understand. And David has a really good answer, 100%. Dude, to me, I actually added 100%. 100% wasn't part of the answers. I just put it in there because I thought it was funny. Like, hey, 100% was 100%. But the correct answer is C, 85%. But it was just funny. To me, when I saw it, I was like, oh man, 100% of all electrical injuries is because of electrical.
Well, when I was thinking about it, I was more on the low end because most of the, we have on the 70 committee where you got reported injuries, but they really wasn't injuries.
Right.
It was more they got shot and they're perfectly fine. So it's really, in my opinion, it's not an injury. An injury to me is somebody that really got hurt. And that's why I was like, that's why I asked the question before I did it. I was like, wait a minute now.
If you want to debate too, I actually got this from NFPA website, so you know what I mean? Like it does say all this in the NFPA journal. The NFPA journal, I want to give a big shout out to NFPA journal. They had a lot of really good statistics in there and stuff that helped me write this.
Yeah,
write this quiz. So
when I was just looking, that's why I was thinking of it that way because, I know we have with the BLS, the Bureau of Labor Statistics, they go in and talk about that they don't get in and they don't list the injuries in there because they don't get reported by the hospital because they didn't get hurt.
Hey, David, if you go into NFPA.com and hit NFPA 70 and then go into NFPA Journal News, it'll give you all the statistics that we're doing tonight. So, but it's not going to be enough for this one. All right. So the NFPA Journal says that it's basically like their motto, kind of, but it's basically like what they are out for. Like their motto. What they're doing. So the NFPA 70 protects buildings from hazards due to installing electrical systems in buildings. A. B. Overvoltage is truly the only real problem we need to fix. C. The NEC is a minimum safety standard. D. One can always exceed the NEC minimum. E. NFPA 70 journal said none of these things. So it could be not even, the NFPA journal might not even have nothing to do with any of this.
Okay, let me start it.
so no answer from David Englehart yet. But there's 4 possible true statements here and 1 possible non-statement at all.
I don't believe the journal says any of those things. I'm going with E.
All right, James locks in E. Still kind of waiting for David to see if David wants to throw in an answer here. Like I say, the NFPA journal is a really valid. Okay, David's got an answer in here. David's got an answer. Yeah, and David goes with D. So David goes with D. One can always exceed the NEC minimum.
Sure they can.
It's just a minimum safety standard. No, good, David. And then James goes with E. All right, so let's just go back to the top 3 that are still left and see what other second answers you guys would decide to choose from the other ones that are still left, because D and E are not correct.
Really? I'll say C.
C, so James locks in with C. And I'm going to give David a second chance. D is a good answer. I mean, that's what a lot of people say a lot of times. We have a new person in the house. Somebody will Day, and it's Daniel J. He wins it. Daniel J. just won the contest tonight. And David Englehart goes to C. That was incorrect, David. And Daniel J., one of my good friends, comes in and smashes it out of the house. The NFPA 70 protects buildings from hazards due to installing electrical systems in buildings. That is exactly right, Daniel. You the man, brother. All right, yeah. DJ comes in the house, brother.
We
awesome,
still got
man.
one more.
All right. So cool. We got one possible winner tonight. You guys could tie, and if you tie, we'll have a 3-way tie. So U.S. workers suffered blank amount of injuries due to non-fatal, and I told you guys earlier this was non-fatal exposures to electricity in 2020. So was that number over 2,380, exactly 2,380, or under 2,380? Good luck, everyone, and I hope you like the song. All right, so good luck against Daniel J. Looks like Daniel J is going. He's going hard in the paint. All right,
he's going C.
He's going under. All right, Daniel's locked in under.
He's over.
James, let's see. James is going C. See David Englehart. David Englehart is David Englehart is copying answers. David Englehart's going A. So the only answer that could win tonight is exactly 2,380. So we have a win by Daniel J. Awesome, coming in here. And, yeah, Daniel, he's doing his observations over there, his company, but Daniel J just swoops in here, takes the win with one good answer. Wow, amazing that a new guy just comes in here and just swoops in and takes the win. That is amazing. I mean, like, I got you guys on the exactly. I get you guys on the exactly, but I don't always do exactly sometimes.
You've done that quite a few times. What are you talking about?
Congratulations. Daniel J is the winner of tonight's quiz, Willie Quiz. swooped in, took the win. He knows that I'm trying to fool you guys, so he just takes a different answer and
That just goes to show I hadn't looked any of that stuff up. So I guess every time it comes up, hell, I have no idea.
yeah. No, it's a lot of fun, but we have a new segment for you guys tonight. I hope you enjoy. This is really awesome because this is the new segment, Wall of Shame.
Here we go.
Alright, welcome to the new Wall of Shame segment where we take pictures from the Wall of Shame. Oh, this one's a good one. This was actually last week's Myth of the Week. Stolen from the Wall of Shame group, and a guy said, we just found this. And instantly, right away, you're looking at the no more than 4 quarter bends between pole points. And you're looking at the securing and supporting within 3 foot from a boxer enclosure.
Oh, yeah.
That's the first thing that came off my head right when I saw it.
That's just ugly looking. I don't know how to say. That's just ugly looking.
Yeah, I mean, there was a lot of comments. People were like, hey, you should put a gutter in there, you know?
That's what I was going to suggest. I would have probably put a gutter in there.
I mean, everyone's like, oh, well, there's fire alarm. It's like the fire alarm doesn't have to be on the same level. You could make the fire alarm go higher and then just offset when it gets to the gutter or the wireway or whatever. But
it looks like some of the boxes below are blocking the other boxes above them.
DJ 85 is like, holy shit, that's all in one strut? Yeah, well, good comment, sir.
That's definitely a wall of shame right there.
Yeah,
that's ugly looking.
The thing is, like, you're basically exceeding your 360, in my opinion. Like, I don't even have to see no more of the run. Like, I go in there, I see that, I'm like, you're exceeding 360. I'm gonna go find it. Like, because if you even do just 2 back-to-back 30s to get around something, I mean. To me, why those outside back-to-backs are hideous.
Well, those outside ones, you already got 180 degrees, and these look like these are pretty long runs up in the thing. So I'm willing to bet you're probably over 360.
Yeah, and then like we kind of said too, with the thing about the conduit entries, like. Inspectors start seeing this kind of stuff, they're gonna be like, hey, let's start checking box fill, because how many conductors did you have to bring through there? And I think I saw earlier if you look at this picture close up, there's like a flex that like comes out of the top of one of them and connects to another one, and you're like, wait, how did you do that? You know, so
well, even let's just hypothetical here. Let's just say they took and put a wireway in there. Now you've got to start looking at how many conductors, because once you get over 30 current carrying conductors, you have to start derating.
Yeah, and that's a valid point too. I've actually pointed that out before. If you're going like number 10, like if you're just using number 10 for your like sizing or whatever, then you for like a 20 amp circuit, then you technically don't need to, derate or anything, because your number 10, if you go off the 75 degree C columns, get up to 35 amps, then you cut that in half, you're still over 20. Or right. I think it was four. You're going off the 90 degree C column for your derating, so then you cut that in half, you're still good for 20. For
it
your
just depends on how many are in there. I mean,
yeah, but Daniel, he has a good point. Hey guys,
yeah, no kidding.
Yeah, like they've done that to us before. Like Like, hey, we just need to get this shit done. And to me personally, like, rather than do those back-to-back 90s on the thing, why not just come in and 90 right down in?
Yeah.
And then stagger, just do 2 struts, and then 90 down in one, 90 back out, and then just do 2 struts, and you know what I mean? You don't need to do that hideous cross thing, you know? But really appreciate you joining tonight. DJ85 is the winner of tonight's Willie Quiz, first ever chat winner of the Willie Quiz. And thanks for joining tonight, Daniel. Really awesome that you came in here and just smashed out the experts. And I know David Englehart, like I say, David Englehart, he has this title on him, CMECP. So one day, Daniel, you will earn the CMECP, maybe. But you have to be a master first. You can't do it. You have to be a master. So you're gonna have to go get your masters first, because you can't be a CMECP unless you're a master first. But I will mentor you through that, Daniel, and get you. Oh yeah, no, yep. You'll get a sticker, Daniel. I will send you a sticker. You'll get a. Do you want the mic hole? You'd have to. You'll just specify what sticker you want.
Hey, David, I'm going to create a new program called the ETCP, the Electrical Trivia Certified Program.
There you
Get
go.
one for that.
Dude, see, actually, Daniel, you're really close. Like, all you have to do is get 2 more right, and you can beat James. Dude, you're hideous right now. You're 2 and 15. You only got 2 right out of 5 weeks.
I just want to stick to code questions. I'm 100% on that. I'm good with that. This other stuff, I hadn't studied that. That's out of my realm.
I was telling Daniel, I was like, dude, I think I know how to fool James a little bit. I think I know his little, like when it's an exact number, you're not going to think it's an exact number.
I never go exact. I just don't believe it's exactly on a 0. I just don't freaking believe that crap.
That's so funny. I got you. No, really awesome show. I really appreciate everyone joining. Really fun. Like, this is so fun. Appreciate you joining tonight, Daniel. Appreciate you joining tonight, David. Really awesome to have everyone come in the chat and just have fun with us. And I make the Willie Quiz not to make anyone look stupid, but I really want people to have that awareness of electrical safety and just like see, like, to me personally, when I saw that number that 85% is direct contact with electrical energy, and there's that 15% that's maybe falling off a ladder or rolling a scaffold across the floor and falling off the scaffold or whatever it was. All these injuries should be prevented, and that's my biggest thing that I want to do is like awareness. Like, how do we prevent this? How do we make this risk hierarchy better? To go in there and figure out, like, how do we remove this hazard 100%? I'm not happy with 85%.
Yeah.
I'm not happy with 15%. I'm not happy with the reciprocal of this percentage. I don't care. I want it to be 0. And how do we do that? How do we do that? That's what we have to do, But I appreciate it, David. David's a pretty good sport. Pretty awesome, David. Thanks for joining us.
I'm laughing mine off too, David.
It's funny, but yeah, I mean, you're gonna have those Dallas Cowboy fans complain a little bit about certain things, but it is what it is.
Well, we'll give a shout out today. My Texas Longhorns just got a commitment from the #1 edge rusher in the country, Colin Simmons from Duncanville High School, who won the state championship last year, who had 30-something tackles behind the line. But the most impressive, last year as a junior, he had 22 sacks. You made a great choice, young man.
Hook 'em horns. I'll give you a hook 'em horns on that one. Jason, yeah, it was. They're trick questions, and we're just joking around. But
Yeah, just having fun.
We just want to get like the people in the chat to jump in, and of course, Daniel is the best apprentice I've ever had. He's really good at bending pipe, and it was funny. I'll tell you a story about Daniel. I was working with somebody, just started this new job, and the guy's like, "Oh yeah, Daniel's the best pipe bender I ever met." And I was like, "Oh yeah, guess he taught him."
I think he had the answer beforehand. Yeah, I call bullshit on this.
No. It was total guess. And Daniel, he just got his journeyman's license in March, and he said that all the information that we were doing from NEC Code and stuff from before helped him pass his test. So that means a lot to me, that our knowledge, our teaching, and stuff that we're trying to bring down the line, helps these apprentices down the line. And
Sure.
To me, that means a lot, that we're trying to push it forward to that next generation. And Daniel, you schooled the masters tonight, Yeah, so Daniel,
the truth comes out; it shall set you free.
he always looked busy. So it doesn't matter if you're doing it right, doing it wrong, as long as you look busy. You just gotta look busy. And I learned that from an inspector. And he says he'd just sit there with the cock gun, and it didn't matter if he's sitting there bullshitting or whatever, and he'd take the cock gun and he'd act like he was cocking something, And then somebody was like, came over there like, "Hey, we're gonna give you a raise." And he's like, "Why?" And he goes, "'Cause you're always busy. Every time he see you, you're busy. You're sitting there doing something, And everyone else sitting there bullshitting and talking about code or whatever they're talking about. But it was this one guy, and he's just sitting there like cocking a random seam in the wall or whatever. And they're like, "Wow, you're doing something." Everyone else is sitting there bullshitting. But he always told that to me as like a words of wisdom, to be like, always make sure that you take your cock gun and just take something with you and act like you're doing something while you're talking to people,
Right.
And it was cool. It was a good, real learning lesson. And I was at that job site I was at with Daniel, and I was like, that's a good lesson. You're not just standing around doing nothing. You're actually doing something. But thanks for joining, Michael. Really appreciate it. Yeah, and I like that.
Actually,
Every electrician needs a wood roll.
I've got one. It even has a little slide thing that pops out for the little extra on it. That's how long I've had that sucker.
Yeah. And so it's really awesome. I mean, I'm sure that we've probably taken up enough of your guys' time tonight. I really appreciate you, James, putting this together. I really appreciate everyone just enjoying my sweet new Wall of Shame song that I just found last night, and I was so proud of. But it means a lot to me to like have you guys join and just share with us and tell us dude, Daniel J, he's a true natural. First time ever coming into the Willie Quiz. He even missed the first question. He didn't even have, so out of 2 questions, he got 50%. And so I was trying to make it easy for James, Daniel. I was trying to give him 30%. You did 50% and still smashed it out of the park. So pretty awesome to have my prodigy Daniel jump in here. Dude, there was no communication on this at all. Like I say, I sent him to you totally confidential. There's no way that anybody could know any answers or know any of the, tricks. But,
Well, you can tell I don't know the answers. I've been messing around.
Well,
it's like somebody goes, "Oh, you get the questions." Like, I never see the questions. It's all for me to try to figure out, and seeing how many I miss on it, that proves it right there.
Well, the thing is that I find it fun to like try to fool you a little bit. The Powerade one was my favorite one because you should have known Derek wrote an article about Powerade. But the thing is, like with the way we are, the way me and you are, like we're gonna see an article about Powerade, we're like, yeah, we ain't reading that. You know what I mean? But it was funny because I saw it and I was like, oh wow, Derek Rissell wrote an article about Powerade, and then I was like, oh man, the first thing I'm gonna write is Derek Bixtel didn't write any kind of article back then, And it was funny because you put it right away. You were like, Derek Bixtel didn't write that, and I was like, I know, because it's too believable for him to not write an article at all.
Hey, you might as well said he wrote it on Gatorade.
I know. That was funny though. You ruled both of them out with the two answers right away.
I go, no.
I know. I was like, oh man. But it was fun. It was fun for me because I saw that right away and I was like, there's no way James is saying that Derek Mixel will write a thing about Powerade.
I would have picked that before Power Rangers though.
You ruled out Power Rangers. There's actually people that's like, hey, you should make a Facebook group called Power Rangers. Oh, it's so funny.
All right, let's wrap it up. I'm ready to go eat. I'm hungry.
All right, bro. Yeah. Appreciate everyone joining tonight. And, thanks for all the great participation. And remember, make every day an easy day.
Peace, everybody. Have a good week. We'll see y'all next weekend.
Deuces.